Question number 52 says that threshold frequency nu naught is the minimum frequency that which a photon must possess to eject electron from the metal surface. It is different for different metals. When photon of frequency this 1 into 10 raised to power 15 second inverse was allowed to hit the metal surface, an electron having 1.988 into 10 raised to minus 19 joule of kinetic energy was emitted. ठीक है, ये फोटो इलेक्ट्रॉन की काइनेटिक एनर्जी थी. कहते जब फोटोन ऑफ फ्रीक्वेंसी इतने was allowed to hit the metal surface, then this much of kinetic energy, then photon electron which was ejected, it was having this much of kinetic energy. Calculate the threshold frequency of the metal. Show that electron will not be emitted if photon with the wavelength of 600 nanometer hits the metal surface. So this is a question from the photoelectric effect. So we will use equation, photoelectric effect equation, that is h nu is equals to h nu naught plus kinetic energy, right? So the radiation which is falling on the metal surface, firstly it will be consumed to remove electron from the metal surface, and minimum energy would be which is minimum energy which is called as work function is required, and then extra energy will be utilized in the form of kinetic energy, right? So bache, we are given with the threshold frequency is nu naught, and photon of frequency this is used. So यहाँ पे न्यू की वैल्यू हमारे पास कितनी है 10 raised to 15 second inverse. So we can substitute the values. H nu minus H nu naught is equals to kinetic energy, or you can say H common, nu minus nu naught is equals to kinetic energy, right? But we need to find the nu naught, so we will not use this. Instead h we will directly put the values, right? That is h nu minus kinetic energy, or h nu minus kinetic energy by h is equals to nu naught, because we are asked, their question is asking about what is the threshold frequency. So you can substitute the values of h, which is 6.626 into 10 raised to minus 34 joule second, and frequency of radiation is 10 raised to power 15, right? Second inverse minus, so kinetic energy is given 1.988 into 10 raised to power minus 19, and again substitute value of h, which is 6.626 into 10 raised to power minus 34, and this will give you threshold frequency, which comes out to be 6.99 into 10 raised to power 14 hertz. So this is the threshold frequency value, right? Next question they are asking, calculate the threshold frequency we have calculated. Now show the electron if electron, we have to show that electron will not be emitted if the photon of this wavelength is used. कहते हैं अगर ये wavelength यूज हो रही है तो फोटो इलेक्ट्रॉन जो होगा वो इजेक्ट नहीं होगा. ऑब्वियसली इसका मतलब तभी नहीं इजेक्ट हो रहा है, इसका मतलब जो रिक्वायर्ड थ्रेशोल्ड एनर्जी थी वो क्या है, ज़्यादा है, और जो रेडिएशन यूज़ कर रहे हैं, ठीक है, in order to eject electron, that is less. So we can use a formula, nu that is equals to c over lambda. We know the c value 3 into 10 raised to power 8 meter per second. Lambda, the wavelength of the radiation used is 600 nanometer, or 600 into 10 raised to minus 9, and this will give you new value 5 into 10 raised to power 14 hertz. So radiation of this much frequency is used, but threshold frequency is 6.99, which is more than this value. It means as nu is, sorry, nu is less than threshold frequency, right? So you, as you can see from equation from 1 and 2, nu is less than threshold frequency. It means that hence the photo electron will not be ejected. Right? If this much wavelength is used, then photoelectron will not be ejected.